All right, so in this one, we're going to look at finding the domain of a radical expression where the inside part's a quadratic here. So before I get started on actually working this out, I just want to look at the graph of it because the graph of these are new to us. We haven't seen what the graph of something like this looks like. Okay. So you can see on the graph there's this space between -8 and 5 that's blank. Those are the numbers that are not in the domain. Okay, so we can't plug in 0 for x is the idea, because you would get a -40 under the square root, and that's not allowed. All right, so the domain, it's going to be all the numbers after 5 and all the numbers before -8. But I just wanted you to see the graph because these square root ones like this are just a little bit different. All right, the way you find the domain of this is the same way as the last one. You want to ensure that the stuff under your square root is positive. So you take everything that's under the square root and say that that has to be greater than or equal to 0. Now, it's been a while, but we've done these before. This is a quadratic inequality. The way that we solved them in the past was we would factor this. We would find the places where it's equal to 0. Okay. It would be x and x, 5 and 8. So these are the two numbers that multiply to give us 40, and they got to subtract to give us 3. So the 8's positive, 5's negative. All right. And so to describe the x values that satisfy this, we would think of it in terms of the graph of a quadratic. That's the way that we did this before. If x minus 5 is a factor, 5 was our intercept. 5 was the place where it equaled 0. It also equaled 0 at -8. All right, and this thing was opening up because our lead coefficient was positive. So the graph of it looks something like this. All right, and because we're interested in where it's greater than 0, we want those places where it's above the x-axis, right, which is going to be all the numbers after 5 and all the numbers before -8. Okay, so our solution set for this inequality was x is greater than or equal to 5 and less than or equal to -8. All right, these are the numbers in the domain for this function. Okay, if you plug in a number that's greater than 5, all right, it's going to work out. It's going to give you a positive under the square root. All right, if you plug in a number that's less than -8, same thing. All right, you could describe it like this. This was algebraic notation. For the interval notation, it was -infinity to -8, which was all the numbers less than -8, union from 5 to infinity. Okay, interval notation, algebraic notation. All right, let's go ahead and do one more. So find all the numbers that you can plug in to this function. Okay, so give it a think real quick. Try to think about the numbers that you just actually are allowed to plug in for x. All right, see if you can find a list of numbers that make sense for all the possibilities that you can plug in for x. All right, let's go ahead. Actually, you know what? Let me look at the graph again. Let's go ahead and look at the graph of what this one looks like. Square root of 25 minus x squared. This one's a little semicircle. So what's neat about this? So the domain here is going to be all the numbers between -5 and 5. All right, those are the two numbers that give you 0, right? And you can't plug in numbers after 5, because if you did like 6, for instance, that would give you a 36 right here, and 25 minus 36 is negative, and you can't take the square root of a negative, so hopefully that makes sense there. Let's go ahead and find it out algebraically. All right, you got 25 minus x squared is greater than or equal to 0. This is what you're interested in. Let's see here. If I were to, you know what? I'm going to rearrange this. I would think of it as negative x squared plus 25. And then I would divide by a negative to make sure that my leading coefficient was positive. So that would give me x squared minus 25 is less than or equal to 0. So right here, I divided by negative 1. That's what I did. So I flipped my inequality symbol. Okay, the places where this function is equal to 0 are going to be at positive 5 and negative 5. Okay, I guess if I wanted to factor it, I could use difference of squares. X plus 5, x minus 5. You can see the x minus 5 is a factor, 5 is an intercept, and it's opening up. But this time, I want the places where it's less than 0, so it's the places where it's below the x-axis, which is all the numbers between negative 5 and 5. That's why those were my answers. Negative 5 is less than or equal to x is less than or equal to 5. That's how you would describe the domain for this function. Yep. So all the numbers between negative 5 and 5 are your answers. Or you could write your answer like that. All right.